don't do that. You pull up on the handlebar and you pull down on the pedal. And then you go pull up. You're all the time pulling up on those handlebars. What are you pulling up on the handlebar for? Why? When you pull up on the handlebar, against what? Against the pedal. And that makes you move better. Ain't that neat? It's like this too. I remember when I was a teenager, man, I was really, really skinny. All my friends weighed more than 100 pounds. All my friends weighed more than 100. I was in the 90s. And about as tall as I am now. Like a toothpick, man. And I remember, this is Scouts Honor. I remember I used to go into the drugstore. And I'd drink milkshakes, I'd do everything I could, you know. And everyone was like, how come you're not gaining weight? You're like, I'm trying, like, okay, couldn't do it. And I would go into the drugstore, and I would get on the scale, and make sure none of my friends are around, and put the penny in. And, oh, 94. Will the day ever come? Will the day ever come, okay? Well, one time I'm over at a friend's house, and my friend had a bathroom scale in the bathroom. And I walks in the bathroom, looks to make sure no one looks. Because I'm always afraid someone's going to come by and say, hey, Hewitt, you don't even weigh 100. Hey, everybody, you know what? Hewitt here don't weigh 100 yet. I was afraid of that, you know? Okay. Anyway, one day I'm at a friend's house in the bathroom. He's got a scale. I look, there's no one coming. I step on the scale, and there it is, 94, right? And the friend walks in. And I grab the sink. I grabbed the sink, gang. I grabbed the sink, and I pulled up on the sink. When I pull up on the sink, finish it up, come on, come on, come on. What happens? The sink pushed down on me, whip, boom, 103 digits. I'm there, okay? Some people get the opposite problem, okay? They weigh too much. They're a little bit maybe self-conscious about the weight. They walk in. There's the sink. The sink's still there, yeah? They walk in. Oh, there it is, a 300. If only they weighed like only 290, right? But 300, and they're feeling self-conscious. What's wrong with a 300? There's 300 pound types. It's 99 pound types. It's okay. It's one world, ain't it? But still, you get a little hung up because you want to be like the norm, right? Now, you're a 300 pound type. You walk in, and your friends come in, and they're just going to look and see the 300. There's the sink. Tell your neighbor what you would do. When you push down on the sink, honey, finish it up. Sink push up on you, make you lighter against the scale, and you get a lower reading. Okay, you can step on like, look at it, be 0, okay? You can do it. Newton's third law. Newton's third law is not so easy for a lot of people. In fact, back at City College, when we used to hire teachers, we would have students come in and let the teachers perform and do a 10-minute gig on the blackboard. And we'd always have a student ask the following question. Because we wanted to ask a question which sounded very easy, but wasn't. Like if you asked a teacher, like, what's the wavelength of the Baumol line for the hydrogen transition? He could say, oh, I see, it's a trip. And he'd say, well, I don't know the answer to that, but I'll look it up and I'll tell you next time. Because that's the kind of question that you know darn well you're not supposed to know the answer to, right? But we wanted to ask the prospective instructors a question for which they thought they ought to know the answer, like an easy question. And we found a very, very easy question that not many people could answer. And the reason they couldn't answer is because they didn't have the framework that you guys have right now. And it's this. First of all, we didn't word the question very nicely. We'd have the students say, hey, when I take an object and I drop it, it falls. There's a force on it, right? The instructor said, yes, that force is called the force of gravity. What's the reaction to that force, teach? Anyone want a job at City College? See if there's anyone in this class who can answer that question. Here it is again. I let go of the play. There's a force acting on it. You saw evidence of that force because you saw it accelerate. Here's your question. If there's a force acting on that, what's the reaction force? E. Talk it up. Anyone sitting next to someone ain't saying anything today? If so, put your hand up and go like this. This person ain't talking to me today, honey. Is that right? Is that right? Okay. Hey, what's the answer? Does anyone happen to know the answer? What's the reaction to the force of gravity acting pulling down on this? Someone want to try it? Lee?
The ball is pulling the Earth up.
Right on. Lee, you got a job at City College, honey. You get through here and get your blah, 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 okay? That's right. Let's suppose I had asked a question like this. When I drop this, the Earth pulls downward on the clay. If I phrased it like that, the Earth pulls downward on the clay. What's the reaction? If you would ask that to a teacher type, the teacher type would say, Earth pulls downward on clay. The reaction is the, check it, see if your neighbor knows. Come on, come on. You see, you guys could answer the question this time because the question was phrased properly. It's how a question is phrased that depends a lot on what kind of answer you're going to get. That's like the monks who were smoking in the monastery. Not supposed to smoke in the monastery, especially in the prayer room, okay? And so one monk sends a letter to the high bishop and says, is it okay to smoke in the, is it okay to smoke while we're praying? And the high bishop could only say what? No, you can't smoke while you're praying. That's a sacrilege. No smoking. And the other monk sends a letter and says, is it okay to pray while I'm smoking? Yes, you can pray anytime. Okay. Do you see what I'm saying? How you phrase the question depends a lot on what kind of answer you're going to get. Okay? So again, if I say the Earth pulls down on this, what's this pulling? And then as Lee stated, the clay is pulling up on the Earth. But you see, just asking the question, there's a force on this. What's the reaction force? The question is not phrased so well. Do you see the difference? Oftentimes when you can't answer questions, it's because the questions themselves aren't clear. When the question's clear, and you kind of know your stuff, then you can kind of pick it up and answer it, yeah? You know, when I drop this, it's quite evident the force is acting in this, because the acceleration is noticeable to us all. Is there really a force pulling upward on the Earth? I tell you what. I'm going to do it again. No, not check your neighbor. I'm going to ask you to be very, very quiet. Notice that the chair is pushing up on you right now. Can you feel the chair pushing up? And you're pushing down, and it's even Steven, so we're all at rest. But nevertheless, the chair's pushing up, right? I'm going to drop this and see if you don't feel all of a sudden the chair rush up against you a little bit. Try it. How many felt it? You didn't feel it. You know why you didn't feel it? Because the mass of this thing is tiny, tiny. Look, here's the idea. Here's the force that pulls this down. Huh? And here's the force that pulls the Earth up. But how about the accelerations of both? The acceleration of this is simply that force divided by its mass. And that turned out to be 10 meters per second per second. We talked about this before. But how about the force that acts on the Earth? The mass of the Earth is like this. And when you take that force acting in a humongous mass, you get an acceleration like this. See it? It's like negligible. And so you don't sense it. But if the Earth were smaller, and this were more massive, in fact, what if this were as massive as the whole world? And we held it like this and we dropped it. How far would it go, gang? Would it go all the way down there?
Halfway.
It would go halfway. That's right, because if this was as massive as the whole world, then this would come down just as much as the Earth would come up, and it'd meet halfway. Ain't that neat? Ain't that neat? So you can take ideas and stretch them, stretch them, stretch them, and they become fascinating. I take a rifle. I fire a rifle. Bam! Any force act on a bullet? Oh, yeah, honey. You know darn well the force acting on a bullet. That bullet accelerates. Humongous acceleration. So you know there's a force on the bullet. Any force kicking back on the gun? Well, let me ask you a question. Can there be a force on the bullet? Can the gun exert a force on the bullet without the bullet exerting a force back on the gun? Can it? No! There's an interaction between the gun and the bullet. So gun pushes on bullet, bullet pushes on. That's the recoil. You fire a rifle, boom, it comes back against your shoulder with a force. How big is that force compared to the force that pushes on a bullet? Same. What would you guys have said about a month ago? Oh, the only a little dinky force on the gun, honey. A humongous force on the bullet. Ain't that right? But you don't say that anymore. You know why you don't say that anymore? Because you got physics. Because you learn in physics. You learn this stuff. You're learning, huh? You're learning the physics, yeah. The forces are equal and opposite. But you know what? The effects aren't. The effects of the force are different. But the forces are the same. You know what this means now? Critical thinking. You have to distinguish between a thing and its effect. Dumb people can't do that. And they get in trouble. We can or can't. We're going to be seeing, okay? Let's look at this. And you fire a rifle. Here's the bullet. Bullet races out. And the bullet has a force acting on it. But that gun kicks back. How much force? Really the same? The same. The same force acting back. Now, the acceleration of the bullet, a lot or a little? Answer begins with an L. A lot. Because here's the mass of the bullet. Here's the mass of the rifle. So here's the acceleration of the bullet. Boom! But here's the acceleration of the rifle. So the rifle only goes back to here. In the same time, the bullet goes from here to here. That bullet is accelerating like bonkers, right? Inside the barrel. Now, when it gets outside, is it still accelerating? No. Now it coasts. We talked about this before. It's accelerating down. That's why it drops. So it follows the curved path. But while it's inside, the forces are the same, but the masses are different. That means that the effects are going to be different. What do you mean the effect? How much it moves. You see? So the big thing only moves a little bit. The little thing moves a lot. And they got the same force. That's the two blocks that I pulled before. I pulled the massive block and the light block, and they pulled toward each other. But the light block moved a lot. Some people say, oh, there's more force on the light one. And you guys say, same force, less mass, more acceleration. Now you got to tie all those ideas together. Force, mass, acceleration. How many people do you know that are good at thinking about three ideas at one time? You hear people say that physics is a tough subject. You know why? Because you got to think of multiple ideas at once. Well, maybe not at once, but you got to consider multiple ideas when you're asked a question. And whenever I ask you any question about acceleration, there's two ideas you're going to consider. Two! You know what your friends out in the street are going to consider? How hard is push or pull. But you guys are going to consider not only how hard is push or pull, but what else? How much mass you got, honey. How much mass is being pushed or pulled. And when you consider that also, now you've got it together. And that's Newton's second law. Okay. And this force here is part of some interaction. Here's the other part. Newton's third law. E. Newton's first law, the idea of mass to begin with, huh? Things have mass, they have a tendency to remain at rest. That rifle has a lot more tendency to remain at rest than a little slug of bullet. Okay, so the masses are different, but the forces are the same. That's today's lesson. And the accelerations are different. That's last time's lesson. Do you see how all those ideas connect? It's the connection of ideas. So you're traveling in the wrong country at the wrong time, and it's totalitarian, and what they do is they capture you, and they say, hey, we got you, honey, up against the wall. And they put you up against the wall, they handcuff you, you look at the wall, you see all these bullet holes in the wall, you say, oh, no. And they put you up against the wall, and some guy comes out with a great big high-powered rifle, and he's got these little eagles over here, and he's got a cap with eagles, you know, eagles are strength or something, okay? And he's polishing his rifle up, he's just going to aim it at you and do you in. And you kind of look at him, and you kind of give him some obscenities, okay? And he says, oh, hey, wait a minute. He says, we're not barbarians here. He says, I'll at least give you one last wish. And you say, One last wish? He said, yeah, one last wish. Here's what you might wish. You could say, okay, I'm guilty.